Hello everyone, my name is Josh and I'm a cybersecurity analyst and boot team content creator. Today we're going to be covering the Windows login for SOC TryHackme room. If you're in the SOC level 1 learning path and you haven't completed this room, well, I'm going to be doing a walkthrough for you guys. So with that being said, let's get started with the Windows login for SOC walkthrough. So we're going to start off with task 1, introduction. And just to clarify, I've already completed this room, but don't worry, I'm going to help you understand how I solved each of the questions, so that way you can overall understand how to get to the answer and what was the problem solving methodology as well. So, pertaining to task 1 introduction, SOC analysts spend most of their time triaging alerts and hunting threats. Using the logs in SIM to tell good from bad, analysts have to know the logs well, how they look, how to interpret them, and what malicious actions they indicate. This room begins your long journey into Windows logging, a key skill for any SOC analyst or DFIR professional. Now I know that was a bunch of acronyms, but don't worry, I'm going to break them down for you. So a SOC stands for Security Operations Center. So what that means is like you can think of that as the brain behind a organization's cybersecurity posture. They are the ones who monitor for threats and overall investigate them. A SIEM stands for Security Information Event Management. If you heard of, for example, like platforms such as like Splunk, Elastic, IBM Curator, those are types of SIEMs. So basically what they do is that they centralize all the logs into one place. For instance, any of your network logs, identity logs, etc. All of your logs are centralized into one place, so that way you aren't bouncing around between multiple portals. So overall, a SIEM centralizes your logs and helps analysts speed up their investigation because all of their logs are in one place instead of multiple places. So overall, faster investigation and faster response. Now pertaining to DFIR, DFIR stands for Digital Forensics and Incident Response. If you heard of, for example, like digital forensics, like the investigators who investigate like compromised machines, that sort of thing, that's the digital forensics side. Incident response is when, for example, like a ransomware incident happens, they're the ones who like put out the fires and that sort of thing. Now pertaining to the learning objectives, we're going to understand how to find and interpret Windows event logs. We're going to learn invaluable for monitoring log sources like Sysmon and PowerShell. We're going to prepare for using the mentioned logs in SOC-SIM in the following rooms. To clarify, the SOC-SIM is basically, let me just open this up in new tab to make it easier. Yes, the SOC-SIM is TryHackme's SOC simulator. If you heard of certifications such as SOC Level 1, this helps you get primed for that. So if you wanted to get more experience with a SOC simulator to understand what happens in the real world of a SOC analyst, this is a great learning opportunity for you and your team as well. There's diverse scenarios. You can improve your triage and analysis skills, and much, much more. So overall, definitely recommend this for SOC analysts, managers, and directors, because overall, it's going to help you better understand the real world investigations and overall how a SOC works in the real world. You're going to get engaged in realistic scenarios and hands-on training as well. To get started, here is the login. Here is the credentials and that sort of thing. You can contact sales, frequently asked questions as well to check that out. So that's what SOC-SIM is. It's a SOC simulator to help you get better understanding of realistic scenarios and hands-on training to help you better understand what the SOC analyst role is about. In any recommended rooms, well, we got a few of them. We're going to remind yourself the logs fundamentals. We're going to learn to practice Sysmon. We're going to learn to query event logs, and we're going to know core Windows processes. If you haven't done those rooms already, I highly recommend them because they're going to give you a foundation to better understand the Windows login for SOC room. Like I said, don't worry. I'm going to help you guys better understand these concepts in this room so that way you don't have to be worried about that or anything. However, if you do want to do these rooms, click on the hyperlinks here, and you'll be taken to each of the rooms. For example, If you wanted to do the Sysmon room, you just click on the hyperlink, and it's going to take you to the Sysmon room. And the same thing for the logs fundamentals, event logs, and core Windows processes as room. Again, it is not mandatory to do these rooms, but if you wanted to, they're there for you to access. Now, pertaining to access, we're gonna use the lab machine for this room. So to get that set up, we're gonna click on the Start Lab Machine button. And on the right, we see the room machine spinning up. We'll give it some time to get started. However, if you want to go the VPN route, the password and username and connection type is listed here. And in about, let's just say 30 to 40 seconds, the IP address is going to show for machine IP. So that way you can go the VPN route. And overall, if you do prefer the VPN connection method, there are your credentials. But if you wanted to learn more, you can also see the instructions as well. And this is how you would use the attack box, any other types of VPN such as Squawker, OpenVPN to get started as well, including the access details, machines, pricing, and frequency asked questions to help you guys out. Alright, so we're going to give it a few minutes for the lab machine to boot up. But pertaining to questions to complete for this task, there is one, which is I'm ready to move on, which will be once the lab machine starts up. So there's no answer needed. So our answer is correct. So we completed task 1. Now let's move on to task 2. What is logged? All right. I will give it some more time. It's almost there. We like progress. All right. Logging overview. Let me explain. Whenever you start a program, create a file, or just log in to your laptop, the event is processed by your OS. OS stands for operating system. Then the OS can log the event, meaning it will append a line to some journal, stating the time, action details, and the user behind the action. Every recorded event is called a log, and proper logging ensures that all user and system activity is recorded, thus helping SOC with the following activities, which can be found here. The first one is incident response. Incident response, logs can show when and how the attack occurred. Pertaining to threat hunting, logs, there we go. Logs allow you to search for signs of malicious activity. And for alerting and triage, logs are a building block of any alert or a detection rule. And now the anatomy, there we go, I pronounced it right, cool. Anatomy of a log entry, task you're trying to, reconnecting, let the machine go. Let's try full screen. Sometimes full screen works better. There we go, like I said. Now we got our lab machine ready to go. Awesome. All right, let me do exit split view so that way we can see the content better. And the lab machine still works as well, so I can clarify that. There we go. All right. Now pertaining to a log entry associated with Windows. Windows is an interesting OS as it has very powerful logging capabilities, but requires a lot of knowledge to read and understand the logs. Your first challenge may be to just open the logs as they are stored in a binary format inside the C Windows System32 Win Event Logs folder. So to see that binary format, we can go to, click on File Explorer, click on this PC, click on C drive. It wants us to go to C Windows system. Let's go with system 32. There you go. System 32. Then we scroll all the way down until we see win event. And then we click on logs. And we can just click on one of these. So for example, we're just going to use system. We're going to go with the example. So let's look for system. Let's click on open. Give it a moment for it to open. It opened up in Event Viewer, which we are going to use in this room. It's a really helpful and powerful tool. But just know these are event logs. But however, if we were to view them, they are stored in binary format if you wanted to use Notepad, for example. However, every EVTX file, event log, corresponds to a specific log category. For example, application logs, they contain events logged by user mode applications like the IAIS web server or MS SQL database. And security logs capture events like login attempts, process activity, and user management. Now, to read these event logs, we will use Event Viewer for this room, which is a built-in tool that allows you to view and manage event logs. To open Event Viewer, search for, let me show you guys how to do that. We're going to use search, and we're going to type in event. There we go, Event Viewer. And then what it wants us to do is press Win plus R, type event VWR, and press enter. So we have 3 ways. So we have 2 ways in how to open Event Viewer. The first one is to search for Event Viewer using Windows Search, which we have done, and then open it that way. The second way is to do Win plus R, and then do event VWR and press enter. Either way works. To make it easy for you guys, I'm just going to go the Windows search route. So we're just going to click on the magnifying glass, and we're going to type in event viewer, then click on it. I'm going to full screen this just to make it easier. And this is what event viewer looks like. Now, once the tool is loaded, which we have done, you may see all system logs parsed, grouped, and ready for analysis. Log sources, that's our log sources. Every event log file corresponds to a single item on the left panel. Log list, now log list. Each row you see is a single event that contains a few properties you can sort by. The first one is keywords. For some events, indicates if the action was successful or not. So for example, audit success. Date and time. The timestamp when the event occurred. System time, not UTC. Event ID. We're going to learn more about these in the upcoming task, so don't worry if you don't understand them right now. Event ID is basically a unique number for the event name. Example would be a failed login is always 4624. And a successful login is 4624. 4624, there you go. 4624 for successful logins. Failed logins, 4625. Now, 3. Log details. The actual content of the log can be found here in a plain text or XML format. You can click on the details tab to see this format in XML. And then finally, the filters menu, which can be found here in actions. What this menu does is that you can use the filter current log in the find buttons to filter the logs. Now, what is logged? There are over 500 event IDs just for the security logs and many thousands of various event IDs in total. Still, not all events are logged by default, and not all events are properly documented. So in this room, we will explore the most helpful logs for daily SOC routines. Now, pertaining to event IDs, don't worry, I got you guys. I have a really helpful resource. So the first one is DFIR scripts Windows Forensic Reference Tools. What this is that it is a self-contained offline capable DFIR. Well, what it contains, there you go, is self-contained offline capable DFIR reference pages for Windows artifact analysis. You can download any tool as a single HTML file and use it anywhere, and it's constantly being updated and maintained. Now I see that there's also a Linux version as well. It's awesome. So if you click on that, nice. Now we got a Linux forensic artifact reference page as well. So for my Linux people, here you go. We're not leaving you guys. We're not letting you guys have no resources. For my Linux people, you got Linux forensic artifact reference page as well for Linux Unix forensic artifacts. But for the Windows side, we're going to talk about Windows security event IDs. So here, what this is that it's the complete security EVTX event ID reference. If you wanted to learn more about a specific security event ID, for example, let's start off with 4624. You can click on it, and it's going to tell you about like investigation notes, category, login or log off, subcategory, login, and it's also going to provide you documentation from Microsoft and the Ultimate Windows Security webpage, which I highly recommend bookmarking because it tells you more about the event ID itself. And pertaining to 4624, it is an account that was successfully logged on. So that is what the Windows Security Event IDs reference is. If you wanted to learn more about a specific event ID pertaining to Windows, it's going to be here. There's a bunch to go through. So overall, highly bookmarking this resource and also Windows Security Encyclopedia as well. These are free resources for you to use, but they're very high quality and overall very valuable to have as resources. So now we're going to answer a question below. Looking at the last screenshot, which event describes a successful login? Well, we know that 4625 is a failed login and 4672 is a special login. But what it doesn't say that is 4624 successful or not. So let's use our trusty Windows Security Log Encyclopedia, and it says that 4624 was an account that was successfully logged on. And also we can see here that it doesn't say, and also it says here that 4624 was an account was successfully logged on. So pertaining to this question, we're going to go with security as our log source and the event ID as 4624, and that is correct. All right, moving on to task 3, security log authentication. All right, pertaining to this, we're going to start out with an overview. As a SOC analyst, you can't know in advance which attack you'll be handling tomorrow and which logs you will need to triage. However, out of all Windows logs enabled by default, the security event log is the one that brings you the most value. Let's start our journey from the two most important security logs: security login 4624 and failed login 4625. We're going to break it down more with this table, with the event ID, purpose, logging, and limitations columns. So pertaining to 4624, it is a successful login. What the purpose of this event ID is that it helps you detect suspicious RDP network logins and helps you identify the attack starting point. From a logging perspective, it is logged on the lab machine, which is the one that you are trying to access. Now, pertaining to the limitations, it can be noisy. For instance, you will see hundreds of login events per minute on loaded servers. Now transitioning to 4625, which is a failed login. What the purpose of 4625 is that it detects brute force, password spraying, or vulnerability scanning. From a logging perspective, it's the same as 4624. It is logged on the lab machine for the purpose of this room, which is the one that you are trying to access. But for 4625, the limitations are that it is inconsistent, meaning that the logs have lots of caveats that may trick you into the wrong understanding of that event. Now, pertaining to the structure of 4624, so that way you can better understand how the details and overall log is formatted. Understand this. A typical Windows server can generate tens of login events per minute, and every event is often comprised of many different fields. Still, you can cover most level 1, level 2 cases just by checking a few core event fields in the image below. You can also read more about the other fields and login types in the Event ID Encyclopedia, which can be found here. You also hear the fields as well as subject, login information, login type, descriptions as well, impersonation level, and much, much more. So pertaining to this image below, the core event fields are login type. There is a couple of login methods. For example, you need to know 10 for RDP, 3 for network, and etc. That's the most important ones. There's also the actual logged in user. Don't forget to note login ID. And also, source IP can be trusted, but host name is not reliable. So overall, in this section, I want you guys to understand what you need. What you need is new login, account name, login type, which is login method, login ID, and the source IP can be trusted, but remember, the host name is not reliable. Now, pertaining to the usage of 4624 and 4625, even experienced IT admins often rely on security experts to distinguish bad from good events, so don't worry if the workbooks below seem complex at first. Take your time and treat this task as fundamental knowledge that way you'll use in practice for many upcoming rooms. Now, to get more information about the overall procedures and steps pertaining to 4625, to detect an RDP brute force, you would open the security logs and filter for 4625 event ID, fail login attempts. Next, you look for events with login type 3, which is network, and 10 RDP logs. And for most modern systems, the login type will be 3, since NLA is enabled by default. And for more information pertaining to NLA, you can click here, open a new tab. And it stands for what is network level authentication, which is it, and it's a detailed guide. Oh yeah, it is very detailed. So if you want to learn more about network level authentication and how it secures remote desktop sessions by requiring users to authenticate before a session begins, this helps protect your system and sensitive data from unauthorized access. Highly recommend checking out this detailed guide, and the URL can be found here. All right. Now, pertaining to older and misconfigured systems, the login type will be 10 because NLA is not used. Now, every event is now worth your attention, but the main red flags to look for are many attempted users like admin, help desk, and CCTV indicates password spraying. Also, many login failures on a single account, usually administrator, indicates brute force. Next, workstation name does not match a corporate pattern. For example, Kali instead of THM-PC-06. Awesome. Source IP is not expected. For example, your printer trying to connect to your Windows server. Now pertaining to how you would analyze RDP logins. First, you will start out with opening security logs and filtering for the event ID 4624, which is associated with successful logins. Then, you look for events with login type 10, RDP logins, and if NLA is enabled, every RDP login event is preceded by another 4624 if login type 3, which is network. And to get a real workstation name, you need to check the preceding login type 3 event. And to help you guys out, because we're talking about login types, the different login types can be found here for the 4624 event ID using the event ID encyclopedia. So the different login types are here. 3 is network, and 10 is remote interactive, such as terminal services, remote desktop, or remote assistance. Pertaining to login type 3 network, you can, for example, a connection to a shared folder on this computer from elsewhere on network. And 3, your red flags are either a preceding brute force or a suspicious source IP host name. And finally, if you assume that the login was indeed malicious, find out what happened next. For instance, Windows assigns a login ID to every successful login. Example, 0x5D6AC. And login ID is a unique session identifier. It can save you time for future analysis and also save it as well. Now pertaining to the questions, we're going to start off with the first one, which is that we're going to open the practice security event log file on the VM's desktop and try to answer the question, which IP performed brute force on the THMPC. We also have a hint as well. Our hint is to filter for the correct event ID and review the event filters. So we're going to go to the lab machine. And of course, it's reconnecting. Okay. Let me refresh. Connecting. Connecting to remote machine. Terminate machine. Oh, should be good. There we got our information. It's just all right. Our machine seems to be connecting. Everything should be good. Let me refresh just to make it easier. All right, our machine seems to be having issues. Let me check to see if I can. And also I can reset the progress of the room as well to start from the very beginning. Start the attack box. Start the machine. Turn it on. I can also terminate the room, terminate the machine if I wanted to. I'll probably do that. Yeah. Since the machine is not working, let me terminate the machine, and then we're gonna start up that machine again. I'm gonna give it a few minutes to boot up again, and then we'll get on with task 3, security authentication, and then we're going to answer these questions. So give it a few minutes. Hopefully this time we'll be able to do the tasks. Sometimes the rooms and overall machines can not be working as expected. So hopefully when we restart the room and overall start a new task, lab machine, overall machine, we'll be able to complete the room. So we got task 3, 4, 5, 6, and 7. All of this is really great information. So we're going to have a lot of fun. And we're going to learn a lot in this really helpful room for Windows logging for SOC. And also our hint for the first question is that we're going to filter for the correct event ID and review the event fields. All right, so it's almost there. So let's give it a few more minutes and then we'll get started. Also, like I mentioned in task 1, if you are using a VPN or want to go the VPN connection method route, here are the credentials: username, password, IP address, and connection type via RDP. And also the connection methods to see the instructions as well, which can be found here. Pricing, etc. for the tag box. And that's instructions. Alright, we should be ready. I see green. We like green. And then show us the Windows symbol. So we can know that the machine has been booted up. Alright. Also, there's a really... Alright, let's see. Come on, Windows. You can do it. Be on full screen. Come on, you can do it. Connecting to remote machine. Yes, it works. Awesome, we're back. Alright. Now, for this question, we're going to use the practice security event file, which can be found on the desktop. So, I believe this one is practice security, and this one is practice Sysmon. So, we're going to use this event log folder file. Double click on it. Give it some time to start. There we go. Full screen event viewer. I said full screen, not responding. Come on. You can do it. Sometimes event viewer needs positive reinforcement. Or it completely froze. That's fantastic. Not. Alright. Not responding. So, okay. If it doesn't want to go that way, let me just do this. We're going to use the Windows search. Type event viewer. Open. There we go. File. Custom. Event viewer. Local. Open saved. Log. Downloads. Desktop. Practice security. Practice security. And give some time. There we go. Now we got our logs. We got 84 events. Now, since we have our logs, now we're going to answer some questions. So, first question. Which IP performed a brute force on the THM PC? So, since we're looking for brute force attempts, we're going to use event ID 4625. So we're looking for a brute force on the THM PC. So we're going to use filter. We're going to filter for 4625. Not 425. 4625. There you go. Click OK. And now I see failed logins. Let's sort by ascending to see your results. And now we're going to try to find THMPC. You see here it's THM admin. Alright, let's see. Since I have it filtered, I'm going to search for THM PC. Find next. Nice. Alright, we got one. And we can see here. Or did it just see super user, source network address, workstation name? But I do not see THMPC in here. Oh, I see computer. There we go. Computer, THMPC, and I see a failed login, and I see that the IP address mentioned is 10.10.53.248. Let's see if that is correct. Nice. Correct. Awesome. All right. Which user has been breached as a result of the attack? It's the next question. And our hint for that is we need to look for successful authentications from the attacker's IP. So now that we know the IP, we're going to take a note of that and filter by, instead of 4625, 4624. Then we're going to find any mention of this IP, which is our attacker's IP. Paste. Or let's type it. Let me just type 10.10.53.248. Find next. Nice. All right, we got a log, and we can see that the account name is administrator. So we're going to see if that is the answer. Awesome, it is. All right, finally. What was the login ID of the malicious RDP login? Note, the login you're looking for has a login type 10. And our hint is that the RDP login follows the brute force and originates from the attacker's IP. So now we need to find a login type of 10. So we can see here our login type is 3. Now we need to look for a login type of 10. So I'm going to try to find, so I'm going to filter by 10. Let's see, login type 10. I said 10. Or can I filter? Keywords. Alright, cancel. The good thing is, it's not close this program. Ah! Technology is not on my side, but it's okay. Event viewer. Open saves log. Desktop. Practice security. Yes. Start fresh. Alright, this time we're going to look for malicious RDP login. So we're going to use our IP and look for a login type of 10 to pull the login ID. So we're going to type in 10.10.53.248 because that's our attacker's IP to look for the login ID of the malicious RDP login for login type of 10. Boom! Nice. Login type 10. Here you go. 10 right there. And our account name is administrator, which was the account that was breached. And here's the login ID 0x183C36D. Let's see if that's our answer. And it is. Nice. We have completed task 3. We're going to move on now to task 4. Security log user management. So pertaining to this, here's an overview. Hey Michael, is SVC _sysrestore your account? I never saw it in the user list before. No. But it's likely some Windows stuff. Better not touch it to avoid any problems in the future. Above is a typical IT department discussion that often leads to ransomware attacks. However, with some knowledge of authentication and user management events, it is trivial to find out the whole history of any user account. And below is a breakdown of the common event IDs you can use, such as, for example, 4720, 4722, and 4738. What these three here, is that a user account was created, enabled, and changed. And the malicious usage can be like, for example, attackers might create a backdoor account or even enable an old one to avoid detection. And also, yes, you can use the Windows Security Event ID reference. So 4720 can be found. Let's see, account management. There we go. For 720, and a user account was created. 4722, a user account was enabled, and for 725, a user account was disabled. And again, if you click on any of these, you can see the category, subcategory, minimum OS, references, and also the event log encyclopedia reference as well. And also you can copy the ID as well. So overall, these are the event IDs for a user account was created, enabled, and changed. Next, to figure out if a user account was disabled or deleted, you would use event ID 4625 and event ID 4726. A malicious usage would be that, for example, in some advanced cases, threat actors may disable privileged SOC accounts to slow down their actions. Now, pertaining to passwords, when a user changes the password, you can see those logs with event ID 4723, there we go. And if a user's password was reset, event ID 4724 can be used as well. And given enough permissions, threat actors might reset the password and then access the required user. And if you wanted to see either a user was added to or removed from a security group, you'd use the event ID 4732 and 4733. And malicious usage would be like, for example, attackers often add their backdoor accounts to privileged groups like administrators. And the structure of these user management events, pertaining to that, is that all user management events have a similar structure and can be split into three parts. The first one is who did the action, or the subject, right here. Who was the target, the object. And finally, which exact changes were made. And the details can be found below. The subject is the account doing the action. Note the login ID field. You can use it to correlate this event with the preceding 4624 successful login event. The object. This can be named differently depending on event ID, for example, new account or member, but it always means the same, which is the object is the target of the action. Now, details is that it is a target group for 4732 and 4733 events. For instance, a user was added to or removed from a security group. Or new users' attributes like full name or password expiration settings for the 4720. A user account was created, event. And the examples can be found here to help you better understand these similar structures, which they all have subject and object and details. Which for 4732 and 4733, you have details as well, but also for 4720, you have attributes. But generally, All user management events have a similar structure and can be split into three parts, which is subject, object, and details. Or if you're dealing with 4720 events, you have attributes. Here we go. And now the usage of user management events. Many real breaches involved at least some user manipulation events. For example, these ransomware actors, so if you wanted to click here to learn more about that. DFI report, highly recommend them. The reports are awesome. Basically what the DFI report is that it is really beneficial reports to help you better understand how attackers do their operations. So overall, the DFIR report will help you better understand how an attack is conducted from beginning to end. You will learn about the different MITRE phases, such as, for example, like initial access, execution, persistence, lateral movement, and much, much more. So I highly recommend bookmarking and looking at the DFI reports, pun intended, because they are really great resources to help you better understand how an attacker operates at each stage of the MITRE attack phase, such as discovery, lateral movement, and much, much more. So I highly recommend bookmarking the DFI report. And now pertaining to real breaches. Many of them involved at least some user manipulation events. So for example, these ransomware actors, which can be found in the DFI report, reset all user accounts to a single password to slow down the recovery. And if we click on this URL, we can see these attackers created a new admin account for persistence. If you don't know what persistence is, basically what persistence is that it is an attacker trying to maintain access on a system by different methods, such as scheduled tasks, admin accounts, that sort of thing. And refer to the workbooks below to learn how to hunt for similar attacks. Such as if you wanted to understand how to hunt for backdoor users, first, you'd open security logs and filter for 4720 and 4732 event IDs. 4720 is when a user account was created, and 4732 is when a member was added to a security group. Next, you would manually review every event, and your red flags are, for instance, no one from your IT department can confirm the action. Next, changes were made during non-working hours or on weekends. Next, the subject's username is unknown or unexpected to you. For example, adm.old.2008 creating new Windows users. And finally, the target's username does not follow a usual naming pattern. For example, backup instead of thm_svc_backup. And 3, if you confirm that the action was malicious, find out the login details, such as you can copy the login ID field from your 4720 and 4732 event. You can find the corresponding login event with the same login ID, and you can refer to the workbooks from the previous task for further analysis. Now that we understand that information, we're going to answer some questions below. We're going to continue with our practice security event log file on the VM's desktop, which hopefully is still working. Awesome. But we're going to look for which user was created by the attacker soon after the RDP login. So we're going to look for, since it is mentioning which user was created, we're going to probably filter for 4720 events. And just as I say, okay, there we go. It needed positive reinforcement. We're going to look for 4720. User account wasn't created. Oh, I clicked on OK. Come on. I need you, filter. All right, we're gonna have to close event viewer. Open. Is it gonna be under custom views, or is it gonna be save logs? All right, here we go. And then we're gonna filter for 4720 events. 4720. Okay. There you go. A user account was created, and we're trying to find which user is created by the attacker soon after the RDP login. And that is going to be SVC sys resource. Let's see if that is the correct answer. Awesome. And also, we can see that the user management logs follow the format that I mentioned. Subject. You have subject. I just want to make sure I have it correct. Subject. Object. And details. Well, actually, this is 4720, so we have attributes. There we go. And so our answer is going to be SVC sys restore. Nice. All right, next. Which two privileged groups was the backdoor user added to? We need to answer them in alphabetical order. For example, administrators, comma, power users. And we also have a hint. Our hint is that the first group is to dump credentials, and the second one is to allow RDP logins. So we're going to use event ID 4732. Because event ID 4732 is going to give us information about a member that was added to a security group. So we're going to filter. Please work this time. Awesome. 4732. And we can see that we see a group name, remote desktop users. Let me just order these to just make it easier. 755, 24. I believe, there you go, 1049, 1055, 1055. There we go. And so we're trying to find which two privileged groups was the backdoor user added to. The first one, and our hint is that we need to find the first group that would dump credentials. And the second is to allow RDP logins. So the first group, dump logins, backup operators. Next one is for RDP logins, remote desktop users. Let's see if that is the answer. Awesome. All right, finally, does the login ID field match what you saw in the previous task? Yay or nay? Let's check that out. So we're going to use this. And we can see that the login ID is 0x183C36D. And if we check out the previous task for comparison, we can see both the login IDs match, which means that our answer is going to be yay. Right there. All right, moving on to task 5. We're going to talk about Sysmon, more specifically process monitoring. So, here's a conversation. Overview. Sarah, have you run any files from the internet recently? Of course not. Why? I've never opened any untrusted files. Well, your IP is trying to brute force our production servers. Above is an example of why SOC teams need more detailed logging than just authentication attempts. Even if you know who is breached, you often don't know how. That's where process monitoring comes in handy. And there are two ways to enable it on Windows. First, 4688. It is in the security log, and is associated with process creation events. The purpose of this is to log an event every time a new process is launched, including its command line and parent process details. However, it is disabled by default, but if you want to enable it, you can follow the official documentation, which can be found here. The other way is through Sysmon ID 1, which is associated with process creation. The purpose of this is to replace 4688 event code and provide more advanced fields like process hash and its signature. However, Sysmon is an external tool that is not installed by default. You can check out the Sysmon official page for more information. Now for a comparison between Sysmon versus Security Log, Sysmon is a free tool from the Microsoft Sysinternal suite that became a de facto standard for advanced monitoring in addition to the default system logins. For this task, we'll jump right into analyzing Sysmon logs, but you can learn more about this great tool in another TryHackme room, which is the Sysmon room. It can be found here. I recommend checking it out. To learn how to utilize Sysmon to monitor and log your endpoints and environments. So, if I were to choose between enabling the basic noisy 4688 event ID or spending some time installing Sysmon to receive more powerful and flexible logs, I would proceed with Sysmon, and you're encouraged to do the same. Once installed, Sysmon logs are found in Event Viewer under Applications and Services. So, to find the information, we would do Application and Services logs. Then we would go to Microsoft, then Windows, and then Sysmon. CYSS. And here, if you click here, we should see our Sysmon logs, which we have here. Event ID 1, for example. And for example, for Sysmon 1 process creation, you can see the amount of information that you get. That is really, really helpful, such as, for example, like parent process ID, parent image, parent command line, user, login ID, original file name, and much, much more. Now, Sysmon Event ID 1 in action. As you can see on the screenshot above, Event ID 1 has a lot of different fields. The most important of these, of which can be grouped as process info, it is the context of the launch process, including its PID, path, or image, and command line. Parent info. This is the context of the parent process. Very useful to build a process tree or an attack chain. Binary info. This is the process hash, signature, and PE metadata. You'll need it for more advanced rooms. User context. This is a user running the process, and most importantly, login ID is the same as in the security logs. And since almost any attack works on the endpoint level and requires at least some process to be launched to breach the system or exfiltrate the data from it, process monitoring is the most important log source for any SOC team. We can use the following workbook below to perform a basic analysis of any process launch. So for instance, to analyze process launch activity, we can first start out with opening Sysmon logs and filtering for event ID 1. Next, we will review the fields from the process in binary info groups. And the red flags to look for is that, for example, an image is in an uncommon directory like ctemp or cusers public. Another red flag is that a process is especially named like aa.exe or whatever this is, .exe. A process hash, such as MD5 or SHA-256, matches as malware on VirusTotal. So you can click here. And if you don't know what VirusTotal is, it's a really helpful website to help you better understand different URLs, IP addresses, domains, or file hashes. So if you wanted to understand if a certain URL, IP address, domain, or file hash was malicious or not, this website does a really excellent job of helping you analyze suspicious, like I mentioned, files, domains, IPs, and URLs to detect malware and other breaches, and you can automatically share them with the security community as well. But note, if you're submitting data above, you need to agree to terms of service and privacy notice. And most importantly, please do not submit any personal information, because VirusTotal is not responsible for the contents of your submission. If you want to automate it, you can check out the API and access your API key as well. All right. Now moving on to step 3. You need to review the fields from the parent process group, and the red flags are: a parent matches red flags from step 2, suspicious name, path, or hash, and a parent is not expected, such as, for example, Notepad launching some CMD commands. 4. If still in doubt, go up the process tree until you're confident in your verdict. For instance, find the preceding event where process ID equals parent process ID in your event. Analyze it by following steps 2 and 3, looking for the suspicious parent, name, path, or hash. And finally, trace the attack chain by filtering all security and Sysmon events with the same login ID. Now we're going to answer some questions below. We're now going to transition to opening the practice Sysmon event log file on the VM's desktop. And we're going to try to figure out which web browser does Sarah use to browse the web. And we have a hint. Our hint is to look for the first process execution events. So we're going to use event ID 1. So we're going to go to event viewer. We're going to scroll up. Event viewer, open save log, desktop, Sysmon. Yes. Awesome. Alright, event ID 1 to look at process execution events. Event 1. Oh, please tell me you're working. Yes. 1. Should filter yes. Now let's go find which web browser does Sarah use to browse the web. So we're going to look in here. There we go. And we see Google Chrome mentioned. Does it mention Sarah? Yes. User Sarah thmpc /Sarah.Miller. And we can see that Google Chrome is mentioned, and Google Chrome is a browser. And that's our answer. Awesome. Now, which file did Sarah download from the browser? And we have a hint. We need the downloaded files will appear in the downloaded folder. So we're going to go here. And we can see that there was an elevation service.exe, but we're looking for the downloads folder. So let's see if I can do find downloads. Find next. There we go. And we can see in Sarah's download folder, we see a ckjg.exe. That sounds very suspicious. That might be our answer. There we go. Now, which URL was the file downloaded from? Note, we need to use other Sysmon events to find out the answer. We have a hint. We can check out the blog post to learn how this works. Alternate data streams. I believe it's going... So we have a helpful resource. So I talked about severe security event IDs. Now we're transitioning to Sysmon. Sysmon event ID reference. We're going to try to find alternate data streams. I believe that is going to be 22. DNS query or file execute. Maybe it's going to be DNS query. Prosecute queries. Yes, I believe this is correct. File stream created, market the web 15. So it's going to be either event ID 15, or we're going to use 22 for DNS. But let me just double check that just in case. AI mode. What is the Sysmon event ID associated with alternate data streams? Event ID 15. Officially named file create stream hash, which can be found here. File stream created, market the web. This is for its logs the creation of named file streams, specifically the zone.event identifier ADS, alternate data streams attached by browsers to downloaded files. It captures the hash of both the base file and the stream content. And the forensic value investigation notes can be found here. Key event fields, noise level, default state, config and tuning notes, attack techniques, and references for really helpful resources as well. And copy the event ID identifier. So 15. So we're going to use that event ID to filter for those events. So we're going to change this to 15. So look at alternate data stream events. And then we're going to try to find the URL that the file was downloaded from. So we're going to look for ckcg.exe. We're going to try to find the URL. Here's zone.identifier from Chrome. So to Chrome. See downloads. And let me see. Alright, our identifier here. Host URL. HTTP, this domain, this folder, and our file. So this is our URL in which the file was downloaded from. And that is our answer. Awesome. All right, moving on to task 6, Sysmon files and network. We have an overview. As you have seen in the previous task, Sysmon can provide much more than just process creation events. It can log file and registry changes, network connections, DNS queries, and many other crucial events. Furthermore, you can configure what to log and what to skip, unlike with the default logs. This room, for example, uses a popular Florian's config, can be found here. But you are free to change it to fit your needs. Let's take a look at 4 more event IDs. The first 2 is for file create 11, registry value set 13. With the security log alternative is 4656 for file changes and 4657 for registry changes, both disabled by default. And the event purpose is to detect files dropped by malware or its changes to the registry. Example for persistence. We also have 3 and 22. 3 is for network connection. 22 is for DNS query. And for a security log alternative, there's no direct alternative, and it requires additional firewall and DNS configuration. An event purpose would be like, for example, you're trying to detect traffic from untrusted processes or to known malicious destinations. And the structure of Sysmon events can be found below. Take a look at the screenshot above. Although every event ID has its own purpose, which we can see here, the fields highlighted in orange follow the same structure. Also note that some critical fields, like login ID or parent process info, are missing. The logic here is that you use the process ID field to find the corresponding event ID, for example 1, process creation, and get the full context there. And the usage of these Sysmon events, Although process creation events provide enough context to detect common breach scenarios, additional logs can be vital to reconstruct the full attack chain and ensure nothing is missed. For example, you need network logs to identify where the data is exfiltrated to, and registry change logs to check which system configuration was modified by threat actors. If you wanted to analyze process activities, you would start out with copying the process ID field from the event ID 1. Next, you would search for other Sysmon events with the same process ID. And the red flags for network connection events to look for are, for instance, connection to external IPs on port 80 or on non-standard ports like 4444, connection to known malicious IPs, and DNS query suspicious domains like .top, .click, or whatever this is. And 4, your red flags for file and registry changes are files dropped to staging directories like ctemp or cuserspublic, a dropped file as a script like .bat or .ps1, or an executable file like .exe or .com. Created files or registry keys are used for persistence. See you on it later. Alright, with that information, let's go answer some questions. We're going to continue with our Sysmon file on the VM's desktop, but in this case, we're going to try to find the file that was created by the downloaded malware to persist on the host. And our hint provided is that the first malware's action after being launched. So since we're talking about which file is created by the downloaded malware, we're going to go look for event ID 11 events. So we're going to filter by event ID 11 to see file creation events. And we're going to find the file by downloaded malware that was created, okay, to persist on the host. So let's go find that file. Chrome. CKG. Chrome. Tempt. Am I missing something? Wait. Start menu. Program. Startup. Delete app.url. That sounds like something that is trying to establish persistence. Or persist. Let's see if that's our answer. Awesome! It is. Next, what is the command and control server malware connected to? Our answer needs to be in format IP, semicolon port, for example, 1.1.1.1, semicolon 80. So let's go figure out. So since we're talking about trying to find the command and control server that the malware connected to, we're going to filter by event ID 3 to look at network connection events. So we're going to filter by 3, click OK. Network connection detected. That's and we see a destination IP 193.46.217.4, destination port. And that's our answer. We have our IP and we have our port, destination IP and destination port. And finally, which domain does the malicious IP correspond to? And our hint is that we need to review the query results and query status fields to choose the correct domain. So this, we're gonna look at DNS events. So we're going to filter by event ID 22. And we're going to try to find the domain does the malicious IP correspond to. So we're going to look for filter. Actually, let me try to find. Just click cancel, and then I'm going to do find. Oh, not again. Why? Event viewer. Save logs. Thank you. Please tell me I don't have to. Okay, good. Where is it? Find. Actually, let me do a filter first. Let's look at DNS events. So we're going to filter by event ID 22. Yes. Technology is cooperating with me. And since it's 5 events, let me expand that category. Expand some more. All right. Is it? Let me just type in. There we go. Now we're sorted by sending events. Try to find a malicious IP. It's not here. Not here. Ooh. Query name. Finally, which domain does the malicious IP correspond to? We see a query name. And we see our file. And we see our user. So I'm going to say that this domain is what is what is used. Yes, we see the domain mentioned, and also we see our IP that the command and control malware, server malware, is connected to, which is 193.46.217.4. So in this case, our domain that the malicious IP corresponds to is going to be this .click. And that is our answer. All right, moving on to task 7, PowerShell logging events. Now, an overview. PowerShell is a powerful tool built into Windows that attackers love to abuse, mainly because it is both trusted and capable of malware download, system discovery, data exfiltration, and even advanced techniques like process injection. However, you won't capture its commands by just using process creation logs like this one event ID 1. Take a look at the command prompt below. We can see the commands entered in the PowerShell terminal: get child item, get content, get local user, get local group, invoke web request. Here, the third actor managed to read a sensitive file, sequence.txt, view local users and groups, and even download malware to the temp directory. Still, you will see a single event ID 1 stating that PowerShell.exe was launched, with no information about the executed commands. So how does this work? Well, every program has a specific purpose. For example, Firefox.exe is a web browser. Notepad.exe is a text editor, and whoami.exe simply outputs your username. If you're just browsing the web, you might only create a single Firefox process. However, with every out-of-the-scope task like RDP access or photo editing, you have to open new programs and create additional logs. PowerShell, on the other hand, is a powerful all-in-one tool for managing the system. Once you launch PowerShell.exe, you can run hundreds of different commands within the same terminal session without creating new processes for each action. This is why Sysmon is not very helpful here, and you'll need to find an alternative logging approach. For instance, there is the PowerShell history file. There are at least 5 methods to monitor PowerShell, each of which has their own pros and cons. And also, while you can check out the logless hunt room and research AMSI and transcript logging topics, in this room, we will focus on a simple but effective way to track PowerShell commands, which is the PowerShell history file, which can be found in this file path. And the PowerShell history file is a plain text file that is automatically created by PowerShell, and it simply records every command you type into a PowerShell window, and it's immediately updated when you press enter to submit a command. An example of what the console host history.txt file looks like. So overall, here are some key notes. First, the history file is very useful for tracking malicious actions, like system discovery or malware download. Also, the history file is created for every user, meaning that you may see 5 files if there are 5 active system users. Also, it survives system reboots, unless manually deleted, and saves all PowerShell commands entered for all time. And finally, it does not log command outputs and does not show script content. Example, when running PowerShell./script.ps1. Now with that information, we're going to review the administrator's PowerShell history on the attached VM. So pertaining to this question, which PowerShell command was executed first? We're going to go to this file path and try to look at the administrator's PowerShell history to figure out which PowerShell command was executed first. We're going to go to File Explorer. Click on SPC, C, Users, Administrator, and I believe it's App Data. That is the next. Yes. App Data, Roaming, Microsoft. I believe it is Windows. There we go. Windows, PowerShell, PS ready line, console host.history. Here is our file. And the first PowerShell command that was executed was get.computerinfo. And that's our answer. Now on to the second question. When did the administrator run the first PowerShell command? We need to format our answer in, for example, like April 18th, 2025. Note, you might need to right-click the history file and open properties to get the answer. But we also have a hint provided to us as well. And the hint is that the PowerShell history file is created once the first command is launched. So we're going to right-click on the history file. We're going to click on properties, and then we're going to look at created, modified, and accessed. So our hint is that the PS history file is created once the first command is launched. So we're going to look at the created date, because the PowerShell history is created once the first command is launched. So the created date is going to be Sunday, May 18th, 2025, 8:49:26 p.m. And that is our answer. Now finally, can you find the flag stored in the history file? The format of this flag is going to be something like THM, brackets, whatever the content of the flag is. Note, you might want to check the PowerShell history of other local users. And the hint provided is that you need to read their own history file. So let's go find the flag stored in the PowerShell history files. It's going to be fun. All right, let's go find the flag. Do we have a flag here? I don't see a flag. So we checked administrators, console, PowerShell history. Let's exit out of this. And let's go to C users. Let's check on Alex. App data, roaming, Microsoft, Windows, PowerShell. PS redline, console host history. I see commands, but I don't see the flag. So let's check out Bob, app data, roaming, Microsoft, Windows, PowerShell, PS redline, console host activity, console host history. And here we go. We have a flag. THM, it was me. And that is our answer. In conclusion, also before I conclude, I want to provide another helpful resource as well for Windows logging for SOC, and that is the Applied Incident Response website. You have resources that are free, which can be found here by clicking on the Resources tab for analysts, such as event logs, lateral movement, memory analysis volatility, credential defense analysis reference. You also have your quick references as well, like Windows processes, WMIC, PowerShell. You also have presentations from some of their public talks, which I highly recommend checking out. Scripts for instant response, additional links, and also the book, which I highly recommend checking out. It is really great. It has a lot of really helpful information that is overall very, very solid, and highly recommend. So if you want free resources along with what is mentioned in the room and along with what I covered, highly recommend checking out the Applied Incident Response website because it has free resources for incident response professionals and also for my SOC analyst friends and folks. Highly recommend checking it out as well. All right. Now on to the final task, which is conclusion. Congratulations on completing this room. By learning how to read and query logs from multiple sources, you are now better prepared to trace real attacks and detect the threat actors on every cyber kill chain stage, like reconnaissance, realization, delivery, installation, and much more. Key takeaways from this room. You know how to read 4624 and 4625 event IDs. You frequently encounter them in your SOC analyst role. Next, you learn how to group the logs by login ID and process ID. This is a great way to quickly see the attack chain. You learn Sysmon, and you make sure how to use it. This gives you the most context about what's going on. And finally, don't forget about PowerShell logging, the console history file. For example, because of its usage in cyber attacks rapidly grows every year. So for example, PowerShell is widely used in cyber attacks, and they are constantly growing rapidly every year. So with all this information, resources, and everything, congratulations on completing this room. And a final question is, hope you enjoyed this room. There's no answer needed, so just click on this, and you have completed the room. All right. And also, here's our AI if you wanted to ask it any questions as well. So overall, that's all I have for the room. We're going to terminate the lab machine. So yes, that's all I have to cover in this room, which is the Windows logging for SOC. We completed all the tasks. So hope you enjoyed this walkthrough. Have a great day, and I will see you guys in the next walkthrough. Peace. Have a good one.